Hello guys, how are you today? So today I'm going to be explaining the applied math past papers. I'm going to be doing this in a different style. So I'm going to be posting 2 questions every around like hour or so. Okay, so that way the videos are short. You get to focus on the 2 questions and I'll take some breaks as well. Okay, I just want to say a big thank you to the person who made this, like took their time and made this sheet, because it has all of the questions and the marking scheme. So I believe the first 10 questions are the past papers for the actual exam, right? Let me just count how many questions we have. So perfect, we only have 10 questions for the actual exam. The rest are mock, so you're supposed to do them by yourself, okay? So we start with the first question. Two particles, P and Q, of masses 2.5 kg and 0.5 kg respectively, are connected by a light and extensible string that passes over a small smooth pulley fixed at the top of a plane. Okay, inclined at an angle of 30 degrees to the horizontal. Particle P is on the plane and Q hangs below the pulley such that the level Q is 2 meters below the level of P. See the diagram. They said when particle P is released from rest, okay, it slides down the plane. So it will slide out, it will slide like this. How will my friction go then? It will go the opposite direction. It will go with my tension, okay? So let us draw all of the forces acting. Here we have the weight and the tension on ball Q. On ball P, we have the normal push, the weight, the tension, and we don't forget about the friction. Very important, we have the friction of the ball. They want us to find the acceleration of P. We know that it's sliding down, right? So if it's sliding down, they didn't tell us that it's sliding at a constant velocity, because it's not like sliding from a constant velocity. We directly assume what? We directly assume that there's gonna be acceleration. So let us find the acceleration of P together. First of all, let us label all of our forces. I'm gonna say this is what? This is weight, right? This is tension, so I'm gonna say weight 1, tension 1. Here this is also tension 1 because the tension is same all throughout this spring or the string, okay? This is my friction, this is my weight 2, and this is what? My normal push N. Now, what do I need to do? I need to resolve. For each one of them, I will resolve them. This is already resolved. I don't need to resolve it. However, this over here is not resolved. So let's resolve it together. I will take my x-axis here, my y-axis here. So this is my y-axis and this is what? This is my x-axis. What is the only force that I need to resolve? The only force that I need to resolve is my weight. And weight along the axis is what? It's W sine theta. And weight on the y-axis is what? Is W2 cosine theta. Okay, so now I need to find the acceleration. They did not give us the value of g, so since they did not give us the value of g, I'm gonna use it as what? I'm gonna use it as g. Or actually, let's not complicate our lives. Let me just use my g as what? I will use my g as 10 meters per second squared. Perfect. Now, I need to find the acceleration of P. All of what we've done yet is just to make our lives easier. We didn't start with anything yet. We just did all of this to make our lives easier. So let us find the acceleration of P. First of all, before I focus on P, let me focus on Q. Why? In Q, I'll be able to find the tension, and thus I will relieve a great weight off of my shoulders if I find the tension, because the tension here is the same as the tension here. So what can I say about particle Q? So I'm gonna write over here for particle Q. What can I say about particle Q? Particle Q will also what? It will also accelerate, but how will it accelerate? I know that particle P will slide down, so my acceleration is downwards. That means what happens? What's my acceleration of Q? It's gonna move upwards. It's all about connection. So if I'm moving downwards, right? If P is moving downwards and it's connected to the same string as Q, then that means it will pull what? It will pull Q upwards. So if it's being pulled upwards, that means in this scenario, the tension is greater than the weight. So first thing I'm going to say is that sigma Fy is equal to ma because there is an acceleration, right? And I know that it goes upwards. Because it's going upwards, what can I assume? I can assume that the tension minus what? Minus the weight, okay? Minus weight 1 is equal to ma. Weight 1 is equal to what is equal to mg. What is g? I said use g as 10. And what's the mass of q? Mass of q is 0.5, so 0.5 times 10, which is how much? Which is 5 newtons. So now, tension minus 5 newtons is equal to 0.5 times acceleration. Okay, so this is for particle Q. Now, where do I move on? I'll move on to particle P because I finished particle Q. I can use the tension now. Particle P. What do I know about particle P? Particle P is not accelerating up and down. It's not moving like this. No, it's not. It's moving left and right. That means what can we say? For particle P, we say it only moves along the slope, along the inclined plane, so along the plane. What does this mean? This means sigma Fy is equal to 0 because it does not move up and down, and sigma Fx is equal to ma. Now this is very important. Sigma Fy is equal to 0. What does this mean for me? This means that my normal is equal to W2 cosine theta. So normal is equal to W2 cosine theta. Now, what does it mean sigma Fx is equal to ma? I will look up and I will see how is it accelerating. It's accelerating downwards, right? So here I will say it accelerates downwards. So because it's accelerating downwards, okay, what does this mean? This means that my weight, okay, is a stronger force than both my tension and my friction. So weight 2 sine theta, which is where? Which is on my slope, which is on my inclined plane. Weight 2 sine theta minus my tension plus friction, okay, is going to be equal to what? Is going to be equal to ma. Weight 2 is equal to mg. M of weight 2 is 2.5, g is 10. So it's how much? It's 25 newtons. So what does this mean? This means now it's 25 minus tension plus F. Okay, this is very important, F. Oh, sorry, my bad. Yeah. It's not 25, it's 25 sine theta, and theta is 30. Theta equals to 30 degrees. My bad. Because it's W2 sine theta, I found W2 25 newtons. So it's going to be 25 sine theta minus the tension plus the friction. What do we know about friction? Friction, we know that it's equal to mu times normal. Mu is the coefficient, normal is normal. So what is mu? They gave us mu to be what? To be 0.2. So it's going to be 0.2 times the normal push. My normal push is what? Is W2 cosine theta. So times 25 cosine 30. Okay, this is my friction. So 0.2 times 25 cosine 30. I'll get my answer to be 4.33. So tension plus 4.33 is equal to the mass, which is how much? Which is 2.5 times acceleration. Now, oh no, don't erase it. Okay, now I have all of my information. I think I may need more space, but that's fine. I have all of my information. What can I do? I can equate both of them. So what does this mean? This means that I will take this. Let me choose a nice color, this red. I will take this equation over here and I will make it equal to this equation over here, right? Or not make it equal to, I can just solve it very easily. So I'm gonna add a page. How do I add a page? 1 second. Add a page. Can I add a sticky note? Oops. I don't want the sticky note. Okay, so I don't think it's gonna work. I'm just gonna zoom in and solve it. Or I'm gonna dedicate this space to solve it over here. So T minus 5 newtons is equal to 0.5A. Yeah? And then 25 sine 30, how much is that? That's gonna be 25 over 2, which is 12.5. 12.5 minus tension minus 4.33 because I distributed the minus. So what's 12.45 minus 4.33? That's gonna be 8.17. So I can just replace this by what? By 8.17 minus tension is equal to what? Is equal to 2.5 A, right? So let me move this a little bit up. Now what can I do? Now I can add them together. So I can add this and this together. So tension and tension will go bye-bye, right? And what am I left with? I'm left with 8.17 minus 5 newtons is equal to 0.5 plus 2.5, which is 3 acceleration. So 8.17 minus 5, that's going to be 3.17, right? So 3.17 is equal to 3A. A is then equal to what? A is equal to 3.17 divided by 3, which is what? Which is 1.06 meters per second squared. So my final answer is over here. Let me just rearrange this. Okay, so that's it for part A. So my answer is 1.06 meter per second squared. We'll move on to part B. It says use an energy method to find the speed of the particles at the instant when they are at the same vertical height. Okay, wait, this is a very, very interesting question. They told us what they told us. They want to find a position, right? So I don't think I'm gonna be able to erase this. Hold on, let me put a picture. Okay, also I need to know some very important information here. So I got my graph, right? Just so you know, we will not be using this because we never took anything like this. They want to find V final, V initial is 0. We need to use a little bit of our thinking. It's a bit tricky, but we can do it, okay? So we know that this is P, and P will move at a displacement of how much? Of X. Let's call this position over here X. Or not, let's not call it X. This is what we need to find. Sorry, my bad. This is what we need to find. Now, if we're talking about it, and we're thinking from a horizontal method, right? Sorry, from a vertical method. We could call this X, right? So, this over here could be what? Could be X. From here till here, all of this is what? All of this is X. Now, this is the hypotenuse. Right? And if I'm not mistaken, the angle over here from the inclined plane was what? Was 30 degrees. As you can see, the angle over here is what? Is 30 degrees. What does this mean? This means I can find the distance that P travels. So this would be what? This would be X times sine 30. So this is X sine 30. Now this distance, X, that P travels, is X sine 30. It's equal to what? It's equal to the whole thing over here, which is 2 minus X. Why? Why exactly? Because the movement upward is equal to the movement downward. So however P moves downward is gonna be the same as however Q moves upward. So X, let me just write that here. X sine 30 equals 2 minus X. After solving, you will get X to be what? To be 4 over 3. Now we need to find what we need to find. Now that we have this, actually our whole life became easier. So we can use the equation now. V final squared minus V initial squared is equal to 2 times acceleration times delta x. How much was delta x? It was 4 over 3. V final squared, we need to find. V initial squared is 0, so minus 0 squared is equal to 2 times acceleration, which we found previously to be 1.06 times 4 over 3. So then you can erase this, and you will get that V final squared is equal to 2 times 1.06 times 4 over 3. This would be what? 2.83. And then you do radical here and radical here. You will get that V final is what? V final is 1.68 meters per second. Okay, very, very important question. So this is the marking scheme. You can check it. Let me just, if you want to screenshot, this is for A. We will not use any of these for B. Which one did I use for B? I used this one over here. This is the one that I used for B. Okay, anyways, we'll move on to the next paper, which is this paper over here. Okay, so this paper, we only have this question, and then I'm gonna stop this video and then I'll post in a little bit. A particle of mass 0.6 kg is placed on a rough plane, which is inclined at an angle of 35 degrees on the horizontal. The particle is kept in equilibrium by a horizontal force of magnitude Pm, acting in a vertical plane containing a line of greatest slope. Okay, the coefficient of friction between the particle and the plane is 0.4. Find the least possible value of P. Okay, so before all of that, let us draw all of the forces acting on the ball other than P. We have the normal push, we have the weight, and we have friction, of course. So now, what do we need to do in this scenario? We will need to resolve, right? How will I resolve? I will take this to be my y-axis, this to be my what? My x-axis. I know that these two angles, first of all, these two lines are what? Are parallel. So what do they form? They form a Z shape. What do I do with the Z shape? This is what? A Z shape, right? What do I do with Z shape? They are alternate interior angles. That means this is also what? This is also 35 degrees. Now what can I do? I like these colors. Now what I can do is that I can resolve. First of all, for the weight, I can resolve it by saying here this is W sine theta, and here this is what? This is W cosine theta. Okay, this is supposed to be known. For Pn, we'll have to draw a triangle, right? So let me just try it over here. First step we're gonna do is we are gonna resolve. Okay? Now, I'm gonna write that we resolved W, okay? W became into W sine theta, this is Wx, and W cosine theta, this is what? This is Wy. Now, we need to resolve Pn. How do we resolve that? We have 35 degrees over here, and I can resolve it into what? I can resolve it into something on the x-axis going in this direction, and something on the y-axis going how? In this direction. So I could take it as a triangle, right? This could be my triangle over here. So then, what would this value over here be? This would be P sine 35. Why? Because it's opposite. Okay, so you'll use sine. And then this value over here, what would it be? Because it's adjacent, it would be P cosine 35. Right? So I resolved P. What do I have? On the x-axis, my P is W. Sorry, why did I say W? On the x-axis, P is P cosine 35. This is Px. And then on the y-axis, it's P sine 35. This is what? This is Py. Now, what do I need to keep constant? I need to keep constant the forces that were already on the x and y axis, which were what? Which were the normal force and what? And my frictional force F. Perfect. Now, what do I know? I know that it is kept in equilibrium. When you see equilibrium, that means it's what? It is in inertia. What does inertia mean? That means sigma Fy is equal to 0, sigma Fx is equal to 0. So I can say now, sigma Fy equals 0, sigma Fx equals 0. If sigma Fy is equal to 0, what would this mean? This would mean that my normal push N is equal to what? My normal push N, first of all, how is it acting? It's acting upwards, right? My normal push N is the only force on the x-axis acting upwards. Then I have two forces acting downwards, which are the Pn, because Pn is acting downwards, and the W cosine theta. So N is equal to Pn, or like Py, which is P sine 35, okay? In addition to what? In addition to W on the y-axis, which is what? Which is W cosine theta. This is sigma Fy is equal to 0. Now sigma Fx is equal to 0. What does this mean? This means everything on the left is equal to everything on the right. That means W sine theta, right? W sine theta is the only thing going to the left. It's equal to what? It's equal to everything on the right, which is the friction, okay? So the friction, I'm going to call it F, which is the friction in addition to what? In addition to P cosine 35. Now what do I do in this scenario? I'm gonna just move this so we can solve a bit. My normal push N would be equal to what? Would be equal to P, which we need to find, sine 35, plus W. How much was my weight? My mass is 0.6 kg. I will use G as 10. Okay, so 6 cosine theta, which is 35. 6 cosine theta is what? It's 4.91. So N is equal to P sine 35 plus 4.91. Now here W sine theta, my W is what? My W is 6. So 6 sine 35 is equal to the frictional force, which is mu times the normal. Okay, in addition to what? In addition to P cosine 35. They gave me the value of mu. Mu is 0.4. So now I can solve it because I have the value of my normal push and I have the value of my mu over here. So it's going to be 6 sine 35. How much is that? That's going to be 3.44. 3.44 is equal to 0.4 times the normal push, which is P sine 35 plus 4.91. In addition to what? In addition to P cosine 35. Now we just need to solve. So 3.44 is equal to 0.4. Oops, my bad. Is equal to 0.4 P sine 35 plus 4.91 times 0.4. That is 1.96 plus P cosine 35. 0.4 times sine 35, how much is that? That's 0.229. So I can erase all of this and I can replace it by 0.229 P. And then P cosine 35, I can replace it by what? I can replace it by 0.819 P. Okay, so now I just move them and I continue adding. So I'll move this to the other side. What will I get? I would get 3.44 minus 1.96, which is 1.48. 1.48 is equal to what? It's equal to 0.229 in addition to 0.819. And I would get this to be 1.048 P. So now P would be equal to what? P would be equal to 1.48 over 1.048. And that would be my answer, which is 1.41. That's it for this question. Here's the answer key. Okay, this is my solving. And this is the first 2 questions of the past papers. There's still 8 more to go, and see you in the next video. So it seems there was a change of plan. It was taking so long to load. So I'm gonna do questions 3, 4, and 5. That way I'm halfway done. And then I'll post this video. Later I'll do the remaining 5. But anyways, let's get started with question number 3. What does it say in question number 3? A block of mass 12 kg is placed on a plane which is inclined at an angle of 24 degrees to the horizontal. A light string making an angle of 36 degrees above a line of greatest slope is attached to the block. The tension in the string is 65 Newton. And then they told us that the coefficient of friction between the block and the plane is mu. Okay, the block is in limiting equilibrium and is on the point of sliding up the plane. Okay, due to the friction. So, first of all, because it's in equilibrium, we can state that sigma Fy equals 0, sigma Fx is equal to 0. Second of all, let's draw all of the forces occurring on the block. We have the normal push, we have the weight of the block, we also have the tension, which is like this. Now what is left for me to do? To choose my x and y axis. This is my y axis, this is my x axis. All I need to do now is to resolve. I know always on the x-axis my weight is gonna be on the inclined plane. Of course, it's gonna be w sine theta. Here it's gonna be on the y-axis w cosine theta. My tension, I just need to resolve it as if it were a triangle. I need to find the value of the x, so it would be tension cosine 36, right? So 65 cosine 36 because my tension is 65. And I wanted to find my y-axis, which is basically this over here because they are parallel, okay? I wanted to find it. How do I find it? By doing 65 sine 36. It's all based on the angle and triangles. And this is going up, it's going up like this. Perfect. So now, what can I say? I can say that I resolved W. So you just need to write whatever you did. Resolve W into Wx and Wy. My Wx is what? My Wx is W sine theta. My Wy is W cosine theta. I also resolved T. I got Tx and Ty. My Tx was 65 cosine 36. How much is that? That's gonna be 52.6, let's say. And then my Ty is 65 sine 36. So how much is that? That's gonna be 38.2 newtons. Now, how much is the mass of the block? The mass of the block is 12 kg, and we're gonna be using G as 10. That means it's gonna be W, which is 120 because M times G, and then W, which is 120 again because M times G, and theta is how much? Theta is the angle of inclination of the plane, which is what? Which is 24 and 24. So now I can find the value. What is 120 sine 24? 120 sine 24 is how much? Is 48.8, right? And 120 cosine 24, how much is that? That is 109.6, okay? So now that I have them resolved, what can I now do? I can apply sigma of y equals 0, sigma of x equals 0. That means the normal in addition to tension y, so normal plus tension y is equal to wy because everything up equals everything down. Sigma of x equals 0, everything left equal everything right. That means W sine theta is equal to tension x. So let me change this to Wx. Wx is equal to tension x plus what? Plus... Ooh, we forgot about a very important force, which is what? Which is the friction. Now they're telling us that it's about to slide up the plane. So if it's sliding up the plane, my friction is gonna be in the other direction, which is downwards. So in fact, it's Wx plus friction, which will give me what? Which will give me tension x. My bad. So now I just need to substitute the values. So my normal, which do they want me to find my normal? No, they want me to find mu. My normal is gonna be equal to Wy minus tension y. What is Wy? Wy is 109.6 minus tension y, which is 38.2. So my normal is 109.6 minus 38.2, which is 71.4 newtons. Okay, and we need to find mu. We know that friction is equal to mu times normal. That means mu is equal to friction over normal. So now I just need to make friction the center of the equation. Friction is equal to tension x minus Wx. So it is 52.6 minus 48.8, which is what? Which is 3.8 newtons. So now mu is equal to 3.8 over 71.4, which is how much? Which is 0.0532. Now I got a bigger value than the answer because let me put it as 0.053. Okay, because I used approximate values. I didn't use the exact values, which is sine, cosine, this. This, you guys should do it in the exam. I just did it like this right now so we can save time, okay? So that's it for question number 3. We'll move on to question number 4. Here's the marking scheme. Okay, we'll move on to question number 4. What does it say in question number 4? It says, a particle of mass 2.5 kg is held in equilibrium on a rough plane inclined at 20 degrees to the horizontal by a force of magnitude T, making an angle of 60 degrees with a line of greatest slope of the plane. Okay, the coefficient is 0.3. They said find the greatest and least possible values of the tension T. Okay, so the person who did this put the wrong marking scheme. That's fine. I found the marking scheme online. Anyways, a particle of mass 2.5 kg is held in equilibrium. Very important. sigma Fy equals 0, sigma Fx equals 0. On a rough plane means that there is friction inclined at an angle of 20 degrees to the horizontal by a force of magnitude T, making an angle of 60 degrees with a line of greatest slope, and the coefficient of friction is 0.3. Find the greatest and least possible values of T. So very simply, I just need to draw the forces acting on the ball other than T. We have the normal push and we have the weight. So what I'm gonna want to do is I'm gonna draw my x and y axis. This is me. Sorry, this is my x axis. No, this is my y axis, sorry, and this is my x axis, right? So now before all of that, I need to find W. W equals mg, so it's the mass, which is 2.5 times g, which is 10, so 25 newtons. Very important. Very easy. Now, what do we need to find? We need to find the weight on the x-axis and the y-axis. So here it's gonna be W cosine theta. Here it's gonna be W sine theta, right? So W sine theta is equal to Wx, and W cosine theta is equal to Wy. Now what do I need to resolve? I need to resolve the tension as well. How do I resolve the tension? I just make it into a triangle, right? This is my triangle. And what do I need to find? I need to find my x and y values. So my y value over here and my x value over here. For my x value, it's gonna be tension cosine 60. And for my y value, it's gonna be tension sine 60. What does this mean? This means tension sine 60 is equal to what is equal to tension y. And then tension cosine 60 is equal to tension x. How's my tension y acting? It's acting upwards. What does this mean? First of all, it's an equilibrium. Sigma Fy equals 0. What does this mean? This means everything up equal everything down. That means normal push plus tension y is equal to what is equal to Wy. Then sigma Fx is equal to 0. What does this mean? This means that, we forgot about the friction, by the way. Yeah, we forgot about the friction. Okay, now this is where the question comes into playing its role. So sigma Fx equals 0, that means everything to the left equals everything to the right. We have two possibilities, right? Because we don't know the value of our tension. We don't know if our tension is more than our weight or not, right? This can be determined by what? By either saying it's tension minus, tension is gonna be equal to, because everything left equals everything right, tension x, I'm gonna call this, tension x is gonna be equal to Wx plus friction, or we could say that tension x plus friction is equal to Wx. This is for us to determine now. How do we determine it now? We know first of all that friction is equal to mu times the normal, right? Normal is equal to Wy minus Ty. And how much is mu? Mu for me is 0.3. So it's 0.3 times Wy minus tension y. How much is Wy? Wy is W cosine theta. So here I can write W cosine theta minus Ty. What is Ty? Ty is T sine 60. How much is sine 60? Sine 60, how much is that? That is radical 3 over 2, so it's basically 0.866 tension, right? Because this is tension y. And what is W? W is 25, right? So W cosine theta, 25 times cosine, how much? Cosine 20. So that's gonna be what? That's gonna be 23.4. Okay, so it's gonna be 0.3 times 23.4 minus 0.866 t. So let me change it to 23.5. I think that's better. Okay, so 0.3 times 23.5, that's gonna give me 7.05. And then 0.3 times minus 0.866, that's gonna give me minus 0.260, or let me keep it as 2598, okay, T. So this is the value of my friction. Over here, what would I get? I would get the maximum tension. Over here, what would I get? I would get the minimum tension. So let's find the maximum tension and the minimum tension together. Maximum tension. Okay, how? Actually, let me change it into tension X. How much is tension X? Tension X is tension cosine 60. So T cosine 60, T cosine 60. And what do I need? Am I looking for T cosine 60 or only T? I'm looking for only T. So now, this is my maximum tension, this is my minimum tension. Maximum tension is equal to T is equal to Wx plus friction over cosine 60. How much is Wx? Wx for me is W sine theta, so it's gonna be 25 sine 25 sine theta. How much is theta? 20. 25 sine 20 plus my frictional force, which I found to be what? Which I found to be 7.05 minus 0. Whatever. Let me put it here. Minus 0.29. Was it 29 or 28? 2895T. Okay. All of it over what? All of it over cosine 60. And I will get what? I will get the maximum tension. So let me solve this a little bit actually. What is 25 sine 20 plus 7.05? That's going to give me an answer of 15.6. I'll just erase this. And I'll replace it by what? I'll replace it by 15.6. And don't forget the minus 2.8, 0.2598t, right? Then what do? I can separate cosine 60 onto both of them. So it would be 15.6 over cosine 60, right? Minus this over cosine 60. Now I can work properly. What does this mean? This means t is equal to 15.6 over cosine 60. What's 15.6 over cosine 60? 15.6 over cosine 60. That's going to be 31.2. So it's equal to 31.2 minus, what is 0.2598 over cosine 60? That's going to be 0.5196t. Now, how do I solve this? I'll move this to the other side. So I will get that my tension T is how much? My tension T is, it's going to be 1 plus 0.5196. So 1.5196 tension T is equal to what? Is equal to 31.2. That means my tension T is equal to what? It's equal to my maximum tension T is going to be equal to 31.T over 1.5196. So how much will that be? 1.5196. And that would be 20.5 Newton. This is for the maximum tension. Now, how do we find the minimum tension? I don't have enough space. So look what I'm going to do. I'm going to shrink this. This is to find the maximum tension. Did you see we did a system of equations? So let me shrink it. We don't need this M. We're going to put it here. Okay. And then let me bring this upwards and then shrink it a bit more. So here's how we find what? Here's how we find the maximum tension. Okay, I'm going to fit it over here. Here's how we find the maximum tension. Actually, it doesn't look nice. Hold on. It's better if it was a bit spaced out, so I'm gonna shrink this part over here. Let me shrink this part. Okay, so I shrunk this part. Now, I did this part to find the maximum tension. We still need one part for us to find what? To find the minimum tension. Let me now move this. Okay, I will move this now over here. So now, what can I use? I can use this space to find what? To find the minimum tension. So my minimum tension T is over here. T cosine 60 plus F is equal to Wx. That means T cosine 60 is equal to Wx minus F. So T is equal to Wx minus F over cosine 60. So what would that mean? That would mean T is equal to Wx. What's Wx? Wx is W sine theta, so 25 sine 20 minus my frictional force, which is what? Which is 7.05 minus 0.2589 T, or 98 T. Let me put 98 T so I don't forget. 98 T, okay? All of it over what? All of it over cosine 60. So now what do I need to do? I just need to solve regularly. So let me just erase this. Okay, so you solve regularly. I'm just changing the sign so we can solve it directly. So the minus will distribute among the bracket and I'll be left with this. So 25 sine 20 minus 7.05. How much is that? That's going to be 1.5. So I can erase all of this and replace it by what? Replace it by 1.5 plus 0.2598 T over cosine 60. Now what can I do? I can separate the cosine 60. So this gets its own cosine 60. This gets its own cosine 60. So now what can I say? I can say 1.5 over cosine 60, which is what? Which is 3. So tension is equal to 3 plus 0.2598 over what? Over cosine 60. That's going to be 0.5196 tension. So you'll move this to the other side and you will get 1 minus 0.5196 will give me my answer, which is 0.4804 tension, okay, is equal to what? Is equal to 3. So tension is equal to 3 over 0.4804, which is what? Which is 6 point what? 6.26. Honestly, for me, I got it to be 6.24, so I'm gonna use it as 6.24 newtons. So that's it for question number 4. We'll move on to question number 5. Okay, question number 5, is it only this one? Yeah. Okay. The velocity of a particle moving in a straight line at a time t seconds after leaving a fixed point O is v meter per second. The diagram shows a velocity time graph which models the motion of the particle from time equal to 0 to time equal to capital T. The graph consists of 4 straight line segments. The particle accelerates from rest to a speed of blah blah blah. They want us to find the value of v. So I like to read again what he told us. He told us that the velocity of a particle moving in a straight line at a time t seconds, okay, after leaving a fixed point O is v. Okay, the diagram shows the velocity time graph which models the motion of the particle from t equals 0 to t equals t. The graph consists of 4 straight line segments. The particle accelerates to a speed of v meter per second in 4 seconds, decelerates at 5. Okay, very important. They give me what? They give me the deceleration over here, which is what? Which is 5 over 3 meter per second squared. Okay, to instantaneous rest over a period of 6 seconds. The particle then travels back towards O, reaching a maximum speed of 3 meters per second before coming to rest at time t equals capital T. Okay, so I can find the value of v very simply. Oh, I'm using this over here, my bad. So they gave me this to be 5 over 3 meters per second squared. I can find the value of v very simply. I have my acceleration, which is 5 over 3 meters per second squared. It's equal to what? It's equal to y minus y over x minus x. So it's supposed to be equal to v minus 0 over what? Over 4 minus 10. So this is actually minus 5 over 3 because it's decelerating, okay? That means it's going to be v over minus 6. V over minus 6 is equal to what? Is equal to minus 5 over 3 meters per second squared. So now, what do? I move this up. My v is equal to what? Is equal to 5 times minus 6, which is minus 30 over what? Over minus 3. So I will get my value of v to be how much? To be 10 meters per second. Perfect. Given that the total distance traveled by the particle from time 0 to time capital T is 68 meters, very important, the total distance traveled is 68 meters, find the value of capital T. We know that the top here is how much? Is 10 meters per second. They want to find the value of capital T, knowing that the total distance traveled is 68 meters. What's the total distance traveled? It's going to be area 1 plus area 2. So I find area 1, I add it to area 2, I will get 68. So I will do area 1 plus area 2 equals what? Equals 68. So I need to find the area of the graph 1 because it's a velocity time graph. It's gonna be base times height over 2. So what's my base? My base is 10, right? Times my height, which is 10 over 2, okay? Yeah. In addition to area 2, how do I find area 2? It's again the same concept, base times height over 2. So it's gonna be what? It's gonna be time capital T minus 10, okay? This is base times the height, which is minus 3 over what? Over 2. So now, I just continue calculating. So 50 plus 3 times T minus 10 over 2 is equal to what? Is equal to 68. So now I'll move 50 to the other side. What do I get? I will get 68 minus 50. What's 68 minus 50? That's going to be 18. So 3t minus 10 is equal to 18, right? And don't forget over 2. So now what do? I will move 3 over 2 to the other side. What will it become? It will become 2 over 3, right? Because look, it's 3 over 2, then I will move it to the other side, so I will do keep, change, flip. So it will turn into what? It will turn into 2 over 3. So 18 times 2 over 3, how much is that? That's going to be 12, right? So that means T minus 10 is equal to 12. What does this mean? This means T is equal to 22. So this is my final answer. T equals 22 seconds. That's it for this video. Thank you guys for watching. I hope you enjoyed and have a wonderful day.